Yeah, but I left them. I left them at the house. All right, here we go. So 4-4, we're converting from standard form to vertex form through the method of completing the square. Completing the square is a process that you go through to go from standard to vertex form. You can actually solve quadratics as well using completing the square, but the other teachers and I taught, we're like, that might be too much information because you already have factoring as one way to solve a quadratic, and then you're going to learn another way on Wednesday how to solve a quadratic. So third way, it would have been too much. So we're just going to use completing the square to convert from standard form to vertex form, okay? So how do you complete the square? You want to complete the square for an expression that is x squared plus bx. It has to be in that form, okay? X squared plus bx, no a, x squared plus bx. You add the square of half the coefficient of the bx term, okay? You add the square of half the coefficient of the bx term. So in other words, take the coefficient of the bx term. What is a coefficient? It's next to a variable. So if I look at the bx term, what's next to the variable? B. So you have to take half of b and then you square it.
Should we write down that equation?
Yes, you should. All right? And you add it to that x squared plus bx expression. What that causes is a perfect square trinomial which can be factored nice and pretty. And you should notice, whatever you get when you take half of b is what goes in that factored form. And it's always like that. It's always like that. That's why it's called a perfect square trinomial. Let's look at an example. So we're going to find the value of c that makes the expression a perfect square trinomial. Then we're going to write the expression as the square of binomials. So is it in the form of x squared plus bx? Yes, there will be situations where there's not. There's a number in front, okay? So now, what's the b? 12. So you take 12 and you divide it by 2. What's 12 divided by 2?
6.
And then you square it. What's 6 squared?
36.
And that's the value of c. C is 36. 36 is what makes this expression a perfect square trinomial. So far, so good?
You have to rewrite it like that?
Oh, no, you don't have to rewrite it.
Okay.
Just doing the 36 equals c will work. But I am going to do this so then that way I can show you how to write it as a square of binomials. Every perfect square trinomial will be written as x plus a number squared or x minus a number squared. The number that goes here is what you got when you took half of b. What do we get when we took half of b?
6.
So x plus 6 squared is basically x squared plus 12x plus 36 when you factor it. And it works that way every time. Every time. Let's look at the next one. What's b?
-6.
Sorry, I should have asked. Is it in the form of x squared plus bx?
Yes.
Yes. B is what? -6. So I have to do what to -6?
Divide by 2.
Divided by 2. What's -6 divided by 2?
-3.
Then what do I do to -3?
Square.
Square it. What's -3 squared?
9.
And that is the value of c. Now, I'm not just writing the -3 just to square it, just, to show all my steps. But remember, whatever number you get when you take half of b is what goes into this parenthesis when you write as a square of binomials.
To do x minus 3.
Exactly. So it'll be x minus 3 squared. And it works that way every time. Whatever this number is what's on the inside of the parenthesis. Questions? Now you need to know this step in order to convert from standard form to vertex form. So here we go. All right? We've talked about vertex form before. This is vertex form. Y equals ax minus h squared plus k. That was from long ago, 4-2. Okay? We're going to go from standard form to that form up there. So we're going to have a value for a value for h, and a value for k. To do that, what we need to do is we need to take that first part, that x squared plus bx part, and we need to complete the square. Okay? So we just take the first part. Everyone all right? Okay. What's b? Negative 14. I have to divide that by 2. What's negative 14 divided by 2? Negative 7. Then what do I have to do to negative 7? Square it. And what is that? 49. Now, this is where it gets a little different. Okay? We have successfully completed the square. But you remember how there was a negative 15 that was there? You just can't forget about it. It's still there. But what you do is that 49 is going to be added to the first two terms, but then subtracted from the C value.
Oh, that's good.
Okay? You add it to the first two terms, the x squared plus bx expression, but then you subtract it from the C value.
So if it was like if you ended up getting a negative number for the square.
No.
When you do that, does that become your C value?
Actually, no. The negative 15 with the minus 49 is actually going to become our K. So remember, we're trying to go from standard form to vertex form. Is everyone okay so far? Now, remember, this first part is a perfect square trinomial, which means it can be written in the form of x plus or minus a number squared. What is that number?
49.
Not 49.
I'm at
Negative 7. So I have x minus 7 squared. And what's negative 15 minus 49?
Wait, hold.
Negative 15 minus...
minus 49? So you gotta add. It's negative 64.
And there it is in vertex form.
Is that?
That's vertex form.
So that's our answer?
That is your answer in black. So y equals x minus 7 squared minus 64 is the vertex form to that standard form of x squared minus 14x minus 15. Okay? We're going to do it again. Okay? Is in the form of x squared plus bx, right? So I have to do what? Divide negative 4 by 2. What's negative 4 divided by 2? And then what I do to negative 2? What's negative 2 squared? 4. That number gets what to x squared plus bx? Do I add it or subtract it here? I add it here, but I subtract it here. So I'm going to add 4 here, subtract 4 here.
You know, you do your little.
Mm-hmm. So now just taking the first few, what does that turn into? That x squared minus 4x plus 4.
X minus 2.
And-
Minus 4.
Well, hold on. What's negative 21 minus 4? Negative 25. You can't forget about that C term from before. You subtract what you got once you've completed the square. Every time. And that's how you use completing the square to go from standard form to vertex form. Questions? Great time to review vertex form. For the first one, or 2A. For 2A, what's the vertex here?
-7. Wait, 7, 7,
And negative 64. Remember, it's always the opposite of the inside and then the outside. What about here? What's the vertex here?
2, -25.
Very good. Great time to review transformations. In 2A, what happened to the original x squared function? It moved
7 to the right.
7 right,
And down 64.
down 64. I would never ask you to graph that. That's ridiculous. Over here, what happened to the original graph?
To the right.
Right 2, down 25. Okay? Questions?
Would you make us graph that one?
No, definitely not. That's too far. All right. Now let's look when when it's not in the form of x squared plus bx. This is where a is greater than 1. What's a in number 3a? It's 6. Okay? So when this happens, you just have to do 2 additional steps. Not 1, but 2. Okay? The first thing you have to do is you have to factor out the a from the first 2 terms. Okay? So factor out the a. Not divide, because remember the a in standard form is the same a as when you're in vertex form. Okay, so I can't get rid of it. So if I factor out the a, which is 6, from the first 2 terms only, what am I left with when I factor out 6 from the first 2 terms? What's 6x squared divided by 6? Just x squared. And what's negative 12x divided by 6? Negative 2x. Okay? Even though, yes, I did say divide to get you guys to get the factors, I'm not getting rid of it. It's just going on the outside. If I distribute this 6 back in, don't I get 6x squared minus 12x? I should. Okay? So that's the first change that you have to do. Okay? Now I can complete the square. What is my new b? -2. And you always base it off of the new b after you factor it out. So what's half of b?
-1.
What do I do to that? Square it. What's -1 squared? 1. Here's the second change. Okay? You still add it here, and you still subtract it here. But here is the difference. Here's the change. This number that goes here is not going to be 1. You need to multiply a by the number you got when you took half of b and squared it. I don't know how to write that. The number you got when you took half of b and squared it. Okay? So a is what?
6.
6. What do we get when we took half of b and squared it?
Wait, yeah.
Positive 1.
So 6.
So then that becomes what? What's 6 times 1? 6. Again, you get it by taking the a value, which is 6, and multiplying what you got when you took half of b and squared it, which was 1. Whew.
So that's it?
I mean, then we write it in vertex form.
Yeah.
All right? So I just bring the 6 down. What is this inside factor to be?
X minus 1
X minus 1.
squared. Then you have negative 87.
Negative 87. And there it is in vertex form. I did not lose my A, and now I have my vertex. So let's recap. When there is an A value, you factor it out of the first two terms only. Then you go through the process of completing the square. But what goes in this last box is the product between A and what you got when you completed the square. Let's do 3B. Is everyone okay? I can always tell when you guys get to that point, you should get extra quiet. You don't want to say nothing when I ask, are there any questions?
That's good observation.
Mm-hmm.
I'm tired.
Can I complete the square the way it is?
No.
No. What do I have to do?
Take the 8 out.
You're out there.
From all three terms?
No.
First
2.
First two. So if I factor out the 8,
X squared.
leaves me with x squared
Minus 2x.
minus 2x.
And then little box. And then little block.
And then the boxes. I like the boxes because they do provide a nice visual. Like, I got to fill in these boxes, okay? Too bad I just ain't got no space. All right. Can I complete the square now?
Yes.
What's B?
Negative 2.
What do I do to B?
Divided by 2.
Divided by 2.
What's negative 2 divided by 2?
Negative 1.
Negative 1.
What do I do to the negative 1?
Squared.
Square.
What's negative 1 squared?
1.
1.
Plug it back into the box. First box.
What goes in this first box?
1.
What goes in the second box?
1 times
8.
1 times 8. The value you got when you complete the square times A, so 1 times 8 is 8. Now I can write it in vertex form.
X minus 1 squared. B plus
What am I missing?
I equals 8.
And what else am I missing? The 8. And there you go. You've written it in vertex form.
That's not too bad.
It's not, but it's definitely some steps that you have to remember. Okay? So remember, to complete the square, you take half of B and square it. But it has to be in the form of x squared plus bx. When there's an A involved, you factor it out from the first two terms only. But you have to remember to multiply the value you get when you complete the square times A to get this number here. Questions? All right.